a little bit of notation here. I'll make this up a little bigger. So this is y, and it's going to be equal to something, and here you have f of x, which is a function. And so when you take what we're going to call the first derivative, you'll have one tick mark here, and then you'll have that one tick mark here between the f and the parentheses. That means that's just what you've been doing. And then dy dx is another term for the derivative. Now when you take the derivative of the derivative, we call it the second derivative. And we put two tick marks. This is kind of funky. This does not mean you're squaring. It means you're taking the derivative of this derivative. Notice there's a little 2 here between the d and the y, and there's a 2 after the x. That does not mean x squared. That's just the notation for that derivative. When you go to the third derivative, we have 3 tick marks, you can see, and then we have a 3 here and a 3 here. Now, when we get, I'm going to do this right here. Let's say we get to the fourth derivative. Well, the tick marks start getting messy, so we write a y here. We put parentheses around it, and that means the fourth derivative. So you've taken the first derivative, the second derivative, the third derivative, the fourth derivative. That simply means you took the derivative of the previous derivative. Is that kind of making sense? And then if we would have this, we'd write f, we'd write those little parentheses, we would write, you're taking a derivative and you're taking it 4 times. It is not f to the fourth, it is not y to the fourth. Lastly, you would write a 4 here, dx, d4. So what the general form is the nth derivative, f of the nth derivative of x, and then d of n here, and dx of n.
Okay, I was not listening, but I think I get it. I was busy doing the finding the second derivative bit.
Oh, like this here?
Yeah.
Okay, so tell me what you got for the first derivative.
There'll be 6x to the fifth minus 8x
Go
cubed.
slow for me. 8x to the what?
8x cubed plus 10x minus 3.
Okay. Did you do the second derivative?
Wouldn't that be 30x to the fourth minus 24x squared plus 10?
Okay. A third derivative?
The jerk would be the 120x cubed minus 48x. Am I correct in that statement?
Did you see minus 2x?
48.
What did I do here? Was there supposed to be 24 here?
Yeah.
And I didn't write it down?
Is that
Okay. Okay, and so then when you took the derivative, you took 24 times 2 and got 48?
Yep.
X to the first?
Yep.
Okay, so the fourth derivative?
I have not gotten that far yet.
Oh, well, can you?
Well, 120 times 3 is, I'm just going to do this in my head. 12 times 3 is 36 x squared
360 x squared?
minus 48.
That's 48. All right. So, here's my question. If I keep taking the derivative, what eventually happens?
You get 0.
You get 0. Why?
Quick question, is that f to the n?
Yes, it is. And I'm going to put 3 dots here. And that means I keep taking the derivative. Why do I eventually get 0?
Because eventually you'll run out of x's.
Right, so that means the previous derivative was a constant, correct?
Mm-hmm.
Would everybody agree with that? Okay. Let's look, I'm going to flip the page here. Ben, I'm going to pick on you. Is that okay?
I I've not finished writing.
Okay. I'm going too fast.
Or is this me not paying attention to that bit? I was working on that bit. So let me dny over dxn, correct?
Yep. And n are always, everybody understand n are natural numbers? You know, the first derivative, second derivative, you know, you don't have the half derivative, that's just weird. Okay. We okay here?
I think so.
All right, Ben. Let's say f of x equals, oh, let's pick the sine of x. What is its first derivative?
Cosine of x.
Perfect. What is its second derivative?
Negative sine of x.
Perfect. What is its third derivative?
Negative cosine.
Very good. What is its fourth derivative?
Sine.
What do you notice?
Never.
Switching.
Right, so it comes back up here, doesn't it, right? Okay, it does not decompose, does it? Does not decompose. What I mean by that, it doesn't go to zero, does it? Right? If I had something like this, f of x equals, let's go 6x to the third. Is that okay, Owen? And I'll put a +3 here. Right? What is the first derivative?
18x squared.
What's the second derivative?
36x.
Just like that?
Yeah.
Okay. What's the third derivative?
36.
And what's the fourth derivative?
0.
And that would be the derivative going on, right?
Yeah.
So we say that this decomposes. Okay? Because eventually you just get 0. Colin, are you happy to see this one?
Yes.
What is its first derivative?
E to the x.
Do I even need to take the second derivative?
No.
So the nth derivative would be what?
E to the x.
Yes? Everybody agree with that?
Mhm.
Doesn't decompose. Right, Grace?
One over 2 square root x.
Is that the same thing? Okay. What's the second derivative?
It will not become zero. This will never become 0, but it will get dang well close.
Negative 1 over 4 square root.
When we have square root? So you're saying here it's 1/4 x to the negative what?
Negative
You're going to subtract 1 from a negative 1/2, right? So here's the problem. So can I write it as a negative 3/2? So can I write it as the square root of x cubed? Right, because your denominator is 2, right? I gave you the hard one. What's the next one going to be? It's going to be a fraction, right? So you can use this. Oh, I forgot the negative here. That's why you're looking at me so weird. Okay.
3 over 8 square
X to the 5th? Perfect. Which is this, right? 3/8 x to the negative 5/2. What about the fourth derivative?
Negative 15.
Negative what?
15.
I think you said 15, right?
Yep.
Over
16.
16
Square root x to the 7.
x to the what?
7.
7. Everybody agree? Is there a pattern here? Dot, dot, dot. F, the nth derivative. Well, it's a negative 1, correct? Here was the first derivative, it's positive. The second derivative, it's negative. The third derivative, it's positive. So can't I say, when I add 1 to n, so like when n was 1, I would square a negative 1 and be positive. When n was 2, I would have negative 1 to the third, it's going to be negative. When this the third derivative, n will be 3, but then I'll have 3 plus 1, it's going to be positive. Everybody got that?
Not really. I'll try.
So tell me the 7th derivative. Well, it's going to be positive.
Due to it being odd.
Every odd derivative is positive. Wouldn't you agree?
Yeah, I can see that now.
Okay. So, here, let's look at these numbers. Here on the first derivative, it's 2. On the second derivative, it's 4. On the third derivative, it's 8. On the fourth derivative, it is 16.
2n.
2 to the nth power. Excellent. What about here? On the first derivative, it's,
That is not exactly what I thought. I thought just 2n, not 2 to the nth power, just 2n.
well, wouldn't it be 2 to the nth power? Because 2 to the fourth power is 16?
Well, what I see is each time we're doubling it from like 2 to 4 to 8 to 16.
Right, so,
Oh! Now it makes sense.
okay. Square root, would people agree? X up here, would you agree? To what power? Right, this power is 1, so the order is 1, 3, 5, 7. Those are the powers, right? 1, 3, 5, 7. It's going up by 2s, correct? So this growth is linear, correct? So it's 2n what?
Minus 1?
Minus 1. Let's check. So far, if I'm on the first derivative, this is 2 to the first. This is x to the 2 times 1, which is 2, minus 1, which is 1. If it's the second derivative, 2 to the second is 4. 2 to the 2 times 2 is 4, minus 1 is 3. Looks like it works, doesn't it? The only thing now is we gotta get that numerator. I'm gonna put a times here. What do you notice? I got a negative, I got 1 times 3 times 5. What's the next one going to be?
My guess is a 7.
7. Then it's going to be a what?
You want me to say it?
What do you think it's going to be?
9.
9. So how do I write that?
N times n plus 2. Am I correct in that statement or no?
It doesn't work. You're saying it's n times n plus 2. So for the first one, do I get 1? For the second one, do I get 1?
Okay, you got me stumped. Just give me a minute to think.
Okay.
I'm open to anyone else having any ideas.
We're gonna pause right there and we'll come back to that one. Austin, this is the last one, okay? F of x is 1 over x, which is x to the negative 1, correct? The first derivative, what is it? I'll give you a hint, it's a fraction.
Negative 1 over x to the,
You're doing great.
would be, is it square root? Is there a square root on the x?
Nope.
X to the 2?
Squared,
Yeah.
correct, perfect. Or this, right?
Yeah.
Same thing, excellent. Second derivative,
Be negative 2 over x to the 3rd.
perfect, which is the same as this, correct?
Yep.
Wait, I don't know if I got the. So negative 2.
Ooh,
times-
is it gonna be negative 2? What's a negative 2
No, it'd
times a
be
negative 1?
positive.
It's gonna be positive. You feel better? Matthew?
Yep,
Okay.
so 2x to the negative 3rd power.
Austin, is he correct?
Would be, yeah, negative 6 over x to the 4th.
X to the 4th, very good. What about the 4th?
Be 24 over x, or be, yeah, 24 over x to the 5th.
Everybody agree?
It's,
Okay,
it's exponentially increasing, I believe. Is that the term?
well, let's take a look. Nth. It alternates, negative, positive, negative, positive, correct? So if I had a negative 1 to the nth, for the first derivative, it would be negative. For the second derivative, it would be positive. For the third derivative, it would be negative, correct? Everybody okay on that? Times. I have a fraction here. Down here is x. On the first derivative, it was a 2. On the second derivative, it was a 3. On the third derivative, it was a 4. What should this exponent be? What? N plus 1. Everybody okay with that?
Yeah.
Alright, so it's a 1, then it's a 2, then it's a 6, then it's a 24. So this is 1, this is 1 times 2, this is 1 times 2 times 3. Would everybody agree? This is 1 times 2 times 3 times 4. The next one would be 120 because I would take 24 times 5, correct? What is this?
Is it n factorial?
It's n factorial.
I
Very
have
good.
no clue what that means.
N factorial means we're excited about n.
I have no clue what factorial means. I don't remember going over that.
Okay, if I have 6 factorial, it means 6 times 5 times 4 times 3 times 2 times 1. Which is the same as 1 times 2 times 3 times 4 times 5 times 6. And notice, every time to go the next one, I multiply by the next bigger number, correct? So the 8th derivative, it would be positive, correct? It would be 8 factorial, whatever number that is. And it'd be over x to the 9th. Is everybody kind of seeing that?
I think so. I'm just going to see if I can find that on my calculator. The factorial.
What kind of calculator do you have?
Casio.
Casio? So if you go to,
Because that'll probably be helpful for the future.
well, I don't like 8 factorial because it's too big of a number. But if I hit 8 and then go to option, and then I think you gotta press that right arrow, the F6, and you gotta go to number, which is an F4. There should be something that says.
Frac?
No, that means fraction. Maybe it's not that. Maybe it's probability. Under probability, do you see where it says x factorial?
Yep.
And it's only 40,320.
Yeah, small numbers.
Small number. Yeah. Factorial grows the fastest. And we do that in BC Calc, prove that factorial grows faster than exponential growth. Okay, because even if you go 2 to the nth power, which is 2 times 2 times 2, well, eventually you go 1 times 2 times 3 times 4 times 5 times 6. So every number you're multiplying is bigger than 2. Does that make sense? Where that grow, that, so you end up, that's your proof right there. It's kind of a ridiculous easy proof. All right, back to here. Alrighty, Austin's done.
We didn't do the other back one. For the numerator for one.
Yeah, I'm saying we're gonna hold on to that one.
Okay.
Okay. The derivative of, this is the same, Callan, is x to the 1/2 plus x to the negative 2, correct? What's the first derivative?
Square root of x.
Take the derivative of this.
Oh.
There's a
So
1
I'm
on
gonna
it.
put it in a fraction.
You can, you want me to put in a fraction? I'll do that.
Well, no, you not.
Pardon?
Let's do the 1/2 x to the negative 1/2.
Perfect, I'll take that. What about this?
1 over x squared.
No, there's a coefficient here, 1. So you gotta multiply these two together.
Negative 2 over.
Can I just leave it? X is to what power?
Negative third.
Negative third. So this is the same as 1/2, 1 over 2 square root of x minus 2 over x cubed, correct? Okay. So now you're gonna use this to take the second derivative. What's that gonna give me? You're gonna take a negative 1/2 times 1/2.
Negative 1/4.
X to the, you're gonna subtract 1 from a negative 1/2. be negative,
Negative 3/2.
yeah, 3/2, perfect. And you're gonna take a negative 3 times a negative 2, and it's gonna give you a,
6.
what's 6, x to the,
Negative 4th.
right, and so we can write this as a negative 1 over 4 square root of x cubed plus 6 over x to the 4th, correct? Colin, I didn't miss you, did I? That's a mistake. I gave you something already,
Yeah,
right?
you did.
Alrighty. Ella, you wanna do the hardest one of all?
I guess.
Okay. So we're gonna, to do the second derivative, folks, we gotta do the first derivative first. Does everybody understand that? To do the third derivative, you have to do the first derivative and the second derivative to get to the third derivative, okay? Alright, this is a very common problem in calc. Ask you to find the second derivative. So what are you gonna do here?
Cosine y times dy over dx.
Perfect. Is equal to?
1 plus dy over dx.
Okay, so that means I will write this as cosine of y dy dx minus dy dx equals 1. Would you agree?
Yeah.
Okay, what are you gonna do now that I did that?
Factor out the dy over dx.
Yeah, and the reason I did this one myself is that I knew I wanted everybody to be on the same side. Does that make sense? And so what do I get? Did you tell me what I get in here already? Cosine of y minus 1, right? And so dy dx is equal to,
1 over cosine y minus
everybody agree with that?
Yep.
All right, now, to take the second derivative, I think it's easier to write it, this is a constant, correct? So rather than do a quotient rule, whenever I see a constant, I write it like this. And I think I told Maria this, didn't I? Didn't I tell you that? Oh, you don't remember? Well, I don't either, I'm just guessing, right? Because now all I gotta do is the power rule, correct? So I'm gonna write the second derivative. What are you gonna have me write out front here?
negative 1.
A -1, and I got cosine of y minus 1 to what power? You're doing perfect. And now I gotta do the chain rule, don't I? So I'm gonna come in here, and I'm gonna take the derivative of this stuff right here, correct?
Yeah.
What's the derivative of cosine? And I'm gonna write times here. Got that? So what's the derivative of the cosine?
Negative sine y dy over dx.
Very good. Times dy dx, because you got that y in there. What's the derivative of minus 1?
0.
0. Everybody got that? Okay, so I'm going to write it like, well, this -1 and this negative sign is going to mean that it's going to become positive. Would you agree with that? Okay, so I got the sine of y over the cosine of y minus 1 squared times dy over dx. Do I know dy over dx?
It's 1 over cosine y minus 1.
It's right here, isn't it? Does everybody see that? I know what it is. I figured it, well, I didn't. She figured it out right away, didn't she? So what I'm going to do now is I'm going to get rid of that dy dx. And I got the sine of y over the cosine of y minus 1 squared times, now I got to replace that dy dx with what I know it is. And what do I get? I'll answer your question in 1 second.
It's not a question, it's the answer.
I'm gonna have her finish it up.
Sine
I'm gonna have you do the next one. What?
Sine y over cosine y minus 1 squared times cosine y minus 1. Oh, I guess you can do
Can I just write it like that?
it. Yeah,
Okay, it's what?
to the third.
Does everybody see that?
Now let's find the jerk.
All right, let's. All right, I'm gonna do it on a separate piece of paper. You ready, Matthew?
Yep.
X squared plus 3xy plus y squared equals 6.
You want me to find second, third, fourth?
We're we're just gonna find the second because I don't want people to hit me finding anything else. So tell me where to start.
First we find the first derivative.
Yep,
That would be 2x
okay,
plus 3 y
so you're
prime.
taking the derivative of this, correct?
Oh,
Right? And the reason I put a dot there is you need to think product rule,
yeah.
okay?
So let me think about that. That would be
You were gonna write 3 dy dx?
yeah. I was going
Yep,
to.
okay. I'm gonna tell you the most popular wrong answer.
So it should be 9 dy dx.
No. You gotta do the product rule.
Okay, so
That's why I put that dot there. You tell me which, you gotta take the derivative of one of those. Which one you gonna take the derivative of?
derivative of 3x is 3.
So you got 3y plus, now you got 3x, and you gotta take the derivative of y.
Y prime.
Okay, I know you write it as y prime, but I'm gonna write it as dy dx, okay? You can keep writing it as y prime if you wish. Plus, now the derivative of this,
That would be 2 y. Y prime.
okay? Equals,
0.
okay? So what I did, I moved all of this to the other side. Are you okay with that?
Mm-hmm.
So you got 3x dy dx plus 2y dy dx is equal to a negative 2x minus 3y. Negative 2x minus 3y. What are you gonna have me do now?
Factor out the dy over dx.
You're gonna get 3x plus 2y is equal to a negative 2x minus 3y. Would you agree with that?
Yep. Divide 3x plus 2y.
And I just can't, okay, a voodooist would cancel out the x's, cancel out the y's, and say I'd have a negative 5 over 5, that's a negative 1. That's what a true voodooist would do. No one in here would do that. Not one of you. Okay? Now, we gotta figure out the second derivative, correct? What must we do this time?
Quotient rule.
Okay? So I'm gonna write what on the bottom?
You do 3x plus 2y. All that in parentheses squared.
And then rewrite it up here?
Yep.
Times the derivative of this, correct?
Yep.
Which is what?
Will be a negative 2 minus 3 dy over dx.
minus a negative 2x minus 3y. Correct? Times the derivative of this.
Which is 3 plus 2 dy with dx.
Then what I did, I multiplied this up. I FOILed it. And I got a negative 6x when I multiply these two. And then I multiplied these two and got negative 4y. And then I multiplied these two. I got a minus 9x dy dx. And then I multiplied these two and got a minus 6y. dy dx. So I multiplied this one by this one by this one by that, that one, and this one by that one. Now what I did here, you see how these are all negative in here? And this is negative out here? That's like a negative 1, so I distributed it, and it becomes this. Now, then I don't have to worry about any negative symbols. Is everybody okay with that? And then I did the same thing.
Okay, so we put a.
There was a minus sign here, right?
Mhm.
Well, that could be written as plus a negative 1, and then when you distribute the negative 1 here, all these signs change. So it was this.
I'm just not gonna do that distributive property because I believe you forgot to put a negative in the 3 plus 2 thing. That should be 3 minus 2.
Right here?
Yeah. Or am I getting that wrong?
No, because I took the derivative of this, it's going to be plus. Derivative of 3x is 3
But don't.
plus.
But since you're changing those signs, shouldn't you put a negative over that and the negative 3?
Oh, you said I should distribute that also there?
Yeah.
Oh, that's a great question. Let's go back and talk about arithmetic. Let's talk about commutativity.
Oh wait, no, you don't.
We're okay?
Yeah.
Okay, because if I gave you something like this, you could tell me that answer.
Yeah, if I set the 2 on both of them, I get it now. I get what I said wrong about that.
Okay, you don't do it that way, do you? You just
No.
do it through the 1, correct? Okay. So you're okay now with this?
Yes.
Okay, so I'm gonna distribute this and I get plus 6x plus 9y plus 4x dy dx plus 6y dy dx. Well, I'm kinda happy because some things die, at least one thing dies. Right? So then I said, okay, what do I have here? I got negative 4y plus 9y gives me 5y.
I made 2 things. I think I may have done this wrong, but I think I might have made 2 things die. Let me see it.
And then I have a minus 9x dy dx plus 4x dy dx, and I get a minus 5x dy dx.
And now I've lost.
So I combine that one with this one.
I cannot see the entire page. Wait. Couldn't you cross out the negative 6y dy over dx, and that, yeah, that's all it's saying.
Would everybody agree? So then I said, okay, that's a little bit nicer, got rid of a lot of garbage. I said, well, this is 5y over 1 minus 5x over 1 times dy dx, which was a negative 2x minus 3y over 3x plus 2y. All of that is over
I'm still working on the,
three
getting the
x
derivative.
plus 2y squared. So all I did was take this and put it here. And since that's a fraction, I wrote those other ones as a fraction.
Okay, so I'm at that. Okay, I'm just thinking. I'm around the same spot, just don't have the entire thing yet. I didn't do the substitution yet.
Okay.
Let's get that back.
I'm gonna multiply by the reciprocal, which is gonna be like this. So I took this thing here and I just said, hey, rather than divide by this, I'm gonna multiply by its reciprocal. So what do I have here? I have 5y over 1 minus 5x times a negative 2x minus 3y over 3x plus 2y. So this is the common denominator. So I'm gonna have to multiply this by 3x plus 2y, and I'm gonna have to multiply this by 3x plus 2y. So now I got 5y times 3x plus 2y
Okay, I'm slightly
minus
behind.
5x times a negative 2x minus 3y over 3x plus 2y times this reciprocal. So this is gonna give me.
Okay. I'm slightly behind. Could you
3x.
pause for
Yeah,
me? So I
I'm
look?
slowing down, I'll give you this to copy. Now I'm gonna distribute and I get 15xy plus 10y squared. Negative here, plus 10x squared. Negative here, plus 15xy. So my second derivative is this. This is cubed, and I wrote it this way. You could write it any way you wanted to, I guess. 10x squared plus 30xy plus 10y squared. And you could probably